Good day, guys. In this video we are going to deal with momentum, impulse, elastic collisions and inelastic collisions and solve different kinds of questions. Okay, welcome to my channel. Please like the video, subscribe and hit the notification button. Okay, this question is from November 2021 question paper. Okay, now it says ball X of mass 10 kg is moving eastwards with a velocity of 2 meters per second. So if you can take note here, they gave you directions. East is to the right, west to the left, north up and south down. Okay, now they say it collides elastically. So you guys must take note of this word elastically. It's a very big hint. Okay, so every time you solve question papers, make sure that you highlight the most important words. With another ball Y of mass 2 kg which was moving with an unknown velocity. So now they want you to focus on diagram A as they specify. Immediately after the collision, ball X comes to rest and ball Y moves eastwards with a kinetic energy of 36 joules. So now you have kinetic energy of this ball, okay, and you know its mass. You don't know its velocity here, but you can find it here. You know the mass and velocity, you don't know the velocity here. So the question will say calculate the velocity Vy. Okay, but before I get there, I will explain the term elastic collision, since we have this big word here called elastically. It's a very big hint on our question. Now let me switch on my writing mode. What is the term elastic collision? When we talk about an elastic collision, we are talking about a collision whereby the total momentum and the total kinetic energy are both conserved. Okay, so that is the definition of elastic collision. The total momentum and total kinetic energy of a closed system remains conserved. That is the elastic collision. Okay, so I hope you guys will write it down. Now let us calculate Vy. So for you to calculate Vy, there is some kind of a complex method that you need to use. Why? Okay, let me try to move it like this. Okay, first things first, you can use the principle of conservation of momentum, but then you will realize that you cannot use it this side. You have a lot of unknowns. You don't know the velocity here, you have the velocity here, and if you were to solve for this velocity, you have two unknowns and one equation, meaning that you cannot solve it. Okay, but for you to solve the velocity here, you can use the equation of kinetic energy. So you are going to say kinetic energy, of which it's Ek, which is equals to half mv squared. Okay, all we want is the kinetic energy of this object. Okay, so it is given, of which is 36, which is equals to 1/2. What is the mass of ball Y? Mass of ball Y is 2 kg into 2 v squared. Okay, now we want this v, so this multiplied by this is going to be 1. If we divide by 1 both sides, is going to be 36. So v squared is equals to 36. Now if you put the square root, you're going to realize that V is equals to plus minus 6 meters per second. Now looking at that arrow, we know that it's going east, and you were also told that after collision ball Y moves eastward with the kinetic energy of this. Okay, so we know that it moves eastward, so the plus minus it's not necessary, it's only the positive value because we're given the direction. Okay, excuse me on this one, let me erase. Alright, now we know the velocity of this object. Now we can calculate for Vy. So for you to calculate for Vy, okay, I'm going to wrap for space. Okay, so this V is equals to 6 meters per second east. Okay, now for you to calculate for Vy, you need to get the momentum before. You must have the initial momentum, which must equal to your final momentum. Okay, so now for your initial momentum, you have two particles, so you are going to, let me go up there and see notation first. You have ball X and Y. Okay, so you are going to have mass X, Vx, plus mass Y, Vy, and Vy is what we are looking for, which is equals to all these, they are initial conditions, so initial, okay, which is equals to mass X, Vx, plus mass Y, Vy, but these ones, they're in the final. Okay, now if we were to substitute X as mass of 10 kg, so you have 10 multiplied by 2. Okay, 10 multiplied by 2 plus mass of Y, which is 2 kg. Okay, so you have 2 Vy. Now Vy, it is unknown in this case. Okay, so now after collision, you know that this ball now is stationary, but you have to show how you go to the zero value. So it's 10 multiplied by 0. You guys must understand that you get a mark for correct substitution. If you have this 10 multiplied by 0, you need to write it down instead of writing a 0. Yes, I know where the 0 comes from, but as a learner, you need to show me that you understand what you are writing. Okay, now this mass, it's 2 multiplied by 6 from this velocity. Okay, now what I'm going to do, I'm going to move this value to the other side, so that I can only be left with 2 Vy, which is equals to, this one will be a 0 plus 12 minus minus 20. Okay, okay, I'm sorry about this. Now you realize that this will be 12 minus 20, which is -8. So negative 8 divided by 2, you find that Vy is equals to minus 4 meters per second. If you want to get rid of this negative, then your value will be 4 meters per second west. Okay, so this is the answer for that question. So the key thing for you to know here is using the kinetic energy equation to find for the velocity of ball y. All right, from there you can now find Vy. Now 4.3, they say the balls were in contact with each other for 0.1 seconds during the collision. Okay, so now the ball were in contact with each other for this time. Okay, calculate the magnitude of the force that ball X exerted on ball Y. Okay, so the force of ball X. Now what we are going to do, I'm going to wrap this one. I believe you guys have wrote it down. Okay, so guys, for you to know the force, you need to equate impulse to momentum. Okay, so impulse, which has a symbol of I, we know that it's equals to F net delta T. Okay, but we both know that F net delta T is the same as change in momentum. Okay, now calculate the magnitude that force X, the force of ball X exerts on ball Y. So for you to get F net is equals to delta P over delta T. All right, now what is the momentum of ball X? So ball X has mass of 10 kg and a velocity of 2 kg, 2 meters per second. Sorry for that. So we have 10 times 2 over 0.1 second of contact. Now we are going to find our net force to be something like, let's see, it's 20 and 200 newtons. Okay, now this will be due east, because force also needs force that ball X exerts on ball Y, but we know that let me see. Okay, yes, the force that ball X exerts on ball Y goes to that direction. That is true. Okay, so now guys, that is your 10 marks, as simple as it is. Okay, I'm going to solve another question, guys. Please respond on the comment section if you have spotted any errors, so that I can fix it. Okay, and please guys, if you are confused, do not hesitate to contact me. Okay, now this is the new question that we are about to deal with. Okay, Now they say ball P of mass 0.6 kg is moving east at a speed of 10 meters per second and collides head on with another ball Q of mass 2 kg, okay, moving west at a speed of 15 meters per second. After the collision, ball P moves west at a speed of 5 meters per second as shown in the diagram below. Okay, ignore the effect of friction and rotational effect of the pulse. Okay, now we are asked to define the term momentum in weights. Okay, the linear momentum of a particle is a vector quantity. You need to note that equal to the product of the mass of the particle and its velocity. Okay, so basically it's a multiplication of mass and velocity, and you need to also tell us that it's a vector quantity. Alright, I'm not going to write the definition down, but you need to know it. It's a free mark, this one. Okay, now calculate the velocity of ball Q after collision. Okay, so let's analyze the scenario. We have okay, they didn't tell us if it's an elastic collision or not, so I cannot make use of the kinetic energy equation. Alright, now and the highlights, guys, an inelastic collision momentum is also conserved in it, but an elastic collision both momentum and kinetic energy are conserved. I repeat, an inelastic only momentum is conserved, but the elastic collision both momentum and kinetic energy remains conserved. Okay, now let me solve. So we have mass of this, which is 0.6. we have mass of Q, which is 0.2. now this side, everything we need we have. This side we have mass and velocity here sorted. Now we have mass, we don't have velocity, so the only thing we need is the velocity of the ball. Okay, so, and check, it's 5 marks. Now let us solve. Okay, draw. You need to know that for you to have a conservation of momentum, the momentum before, which is P initial, must equal I would say change in P, which is equals to the change in momentum final. Okay, now let us break it down. You must look at the scenario. Okay, we have two balls coming from two different directions. Even after collision you have two separate balls. Even when you substitute, the equation must match your scenario. There are different scenarios. Sometimes after collision the balls move together as one element. You need to know what happens in such a situation. Okay, now we are going to have a mass of P, velocity of P, plus mass of Q, velocity of Q, which is equals to mass P VP. This one is final, this one I'll make it initial, plus MQ VQ final. Alright, now you need to substitute values. So MP is 0.6 kg. Now we are going to have 0.16. I'm sorry about that, and multiplied by 10. okay. Now plus this mass is 0.2 into 15, but this needs to be negative 15 because it goes to the opposite direction. And mass NP is still 0.616, I mean, multiplied by the velocity there, which is 5, and it's going west, so I'm going to substitute with the negative, plus mass of Q 0.2 VQ final. That's what we are looking for. Okay, now let us simplify the left hand side. Okay, you can use your calculator to do that, and then so the overall this side you are going to have a negative 1,4, okay, which is equals to we have a 0.8, but it's going to be negative plus 0.2 VQF. Alright, so I just simplified the calculations. Now I'm going to transpose 0.8 to the other side. So this minus 1,4, so I'm going to have minus 0.6, which is equals to 0.2 VQF. Alright, now if I divide by 0.2, we are going to have 3. So VQF final is equals to 3 meters per second west. Okay, because you can see that 0.3 from here is going to be negative, so the answer is due west. Okay, now magnitude of the impulse during the collision, impulse on P during the collision. So we need magnitude of the impulse. Okay, so what we can do, since they said magnitude of the impulse during, so what you need to do, remember impulse is equals to change in momentum. That is the first thing that you need to know. Now this thing likes to jump. Looking at ball P, take note that the initial direction goes to east, then the final direction goes to west. Okay, so now when we solve the question, you first need to indicate that impulse, which I will symbolize with I, is equals to F net delta T. But we know nothing about the force, we know nothing about the time, but we also know that impulse is equals to change in momentum. Okay, and change in momentum is the same as M delta V, which is equals to, we're dealing with ball P. Mass of ball P is 0.16. Now the initial velocity that we had, it's 10 minus, since the final velocity goes to the opposite direction, it will be another minus 5. Now it's going to be positive, then it becomes 15. So we have a 0.16 multiplied by 15, which is equals to, unfortunately I cannot do this one by head, times 15, it's 2.4. Okay, I'm sorry. kg meters per second. Okay, and this becomes my final answer. Okay. Oh, and what will be the direction? I'm sorry about that. Since it's a positive value that we got, it will be due east. Okay, so we are done with this question. Free 10 marks. Okay, now let us talk about this question. A bullet moves east at a velocity of 480 meters per second. Okay, it hits a wooden block that is fixed to the floor. Okay, now the bullet takes 0.01 seconds to move through the stationary block. So for the bullet to move from this point to this point, it takes this time. Okay, and emerges from the block at the velocity of 80 meters per second. So the entire 400 meters per second has been lost throughout east. Okay, now they say consider the bullet block, the block bullet system as an isolated system. Now explain what is meant by an isolated system. Okay, when we talk about an isolated system, we are talking about a system whereby it doesn't interact with its surroundings. Whatever that's going to be lost or whatever that changes here, it has nothing to do with the outside world besides these two objects, the bullet and the block. You understand? So you do not consider any external force like a frictional force. That is your isolated system. You will find a good explanation in a book. Now, the magnitude of the momentum of the bullet before it enters the block, it's this. Calculate the mass of the bullet. Okay, alright. Now calculating the mass of the bullet should be easy. Momentum, by the way, when I'm writing here you cannot notice that it's a small letter P, but it is. Okay, now momentum is equals to mass multiplied by the velocity. We don't know the mass, but we know the momentum, which is 24. Then we have mass multiplied by the velocity, which is 480. Now if we divide the two, you will find that it's 24 divided by 480. Now you find that mass is equals to 0.05 kg. So 1, 2, 3, this is like 50 grams. Okay, now 3 marks, 1 mark formula, 1 mark substitution, 1 mark final answer with units. Now 4.2.2, calculate the average net force exerted by the wooden block on the bullet. Okay, now if they want the average net force, first things first, we can say change in momentum, F net delta T is equals to a change in momentum. Okay, now F net is equals to change in momentum. The mass of the bullet is 0.05 into the velocity before was 480, the velocity after it's 80, divided by the time taken for the bullet to be inside the block at 0.01 seconds. 0.01. So that is the force. Now let us try to get the value here. Now I find the force to be 2,000 newtons. So it is due east because the force weight, it's the force on what? On the bullet. So this one would be west if it is required for you to write the direction, okay? Because the wooden block exerts the force in that direction to slow down the bullet. Okay, I guess this will be it from me today, guys. If you did like the video, do not hesitate to like it, subscribe to my channel and hit the notification button. By the way, I'm a tutor for physical science. Should you need my services, please reach out to me and we can make necessary arrangements for personal attention. Okay, cheers guys, and enjoy your day.